Now, let's take a look at the introduction of titration. First of all, what is titration? Titration is a process of chemical analysis in which the quantity of the constituent of a sample is determined by adding to the measured sample with the other solution. Titration is applied to analyze two organic compounds, which is benzoyl peroxide and benzoic acid, that widely used in pharmaceuticals. The first organic compound is benzoyl peroxide. Benzoyl peroxide is a well-known oxidizing agent that commonly used as an acne treatment. Meanwhile, benzoic acid is an aromatic carboxylic acid that used in our product skincare. By performing a titration, the amount of benzoic acid present can be accurately determined, ensuring product quality and safety of the product skincare itself. Next, let's move on the objective of our research. There are three important objectives that we found. The first one is we aim to determine the amount of benzoic acid present in a given sample by using an acid-based titration method. The second one is we aim to sanitize a sodium hydroxide NaOH solution and apply it in a back titration. And last but not least, we aim to accurately quantify the benzoic acid content in our skincare product.
Okay, next is type of titration. In skincare product development and quality control, titration is used to measure concentration, acidity, pH, and active ingredient. Here are the main types of titration used in skincare. First, acid-based titration is the most common use. Acid-based titration is used to measure and adjust the pH of skincare product. Second, to determine concentration of acidic or basic components like benzoic acid. For example, titrating benzoic acid with sodium hydroxide to confirm preservative level. Next is redox titration, oxidation reduction. Okay. Redox titration is used to determine the antioxidant strength or concentration. And third is complexometric titration. This titration to measure the metal ion concentration such as calcium or magnesium in ingredient like water or mineral-rich formulation. For example, titration using EPTA to test for hardness in water used for formulation. And last one is precipitation titration. Okay, it's actually rare in skincare but may be used for analyzing chloride ions or other salt in raw materials. Okay, acid-based titration used in skincare. Okay, acid-based titration is used in skincare because formulation primarily to accurately determine and control the pH of products. This is crucial because pH affects skin health, product stability, and ingredient efficiency. By using titration, formulators can ensure that skincare products are within the desired pH range, preventing irritation and maximizing the effectiveness of active ingredient. Okay. This is why it's important because first is pH and skin health. The skin has a slightly acidic pH around 5.5, okay, so that helps maintain its protective barrier and microbiome. Skincare products need to be formulated within a specific pH range to avoid disrupting this natural balance, which can lead to irritation, dryness, or other skin problems. Okay, next is quality control. Titration is a reliable method for quality control in skincare manufacturing. It ensures that products consistently meet the desired pH specification batch after batch. The third is ingredient efficiency. The effectiveness of many skincare ingredients like certain acid or vitamin can be pH dependent. Titration helps to determine the correct pH to optimize the performance of this ingredient. The last one is product stability. pH affects the stability of ingredients in skincare formulation. Some ingredients may degrade or become less effective at certain pH level. Titration helps ensure that the product remains stable throughout its shelf life. Okay. Actually, acid-based titration involves reacting a solution of unknown pH, the analyte, with a solution of known pH until the reaction reaches a neutral point. Indicators are often used to visually signal the equivalence point by changing color. For example, in skincare, a strong base might be used to titrate a slightly acidic formulation to determine the exact amount of acid present. This allows the formulating to adjust the pH to the desired level by adding more base or acid as needed.
So hi, this is my part. What is titration? Process of chemical analysis in which the one solution of known concentration titrate slowly added to a known volume of another solution of unknown concentration until the reaction reaches neutralization, which is determined by color change. The process is usually carried out by gradually adding a standard solution of titrate until the equivalence point is reached. At the equivalence point of a titration, an exactly equivalent amount of titrate has been added to the sample. So the titration has two types. The first one is acid-based titration direct. Acid-based titration directly determines the unknown concentration of an acid or base by reacting with a solution of known concentration, known as the titrant, until the reaction reaches a neutralization point, typically indicated by a color change from a pH indicator. For the next is acid-based titration back. Back titration in acid-based reaction involves adding an excess of a known or base or acid to an unknown sample. and the titrating the remaining excess acid or base with a standard solution of the opposite type to determine the initial concentration or amount of the unknown analyte.
I follow you into the park, feel the jungle fever. Gonna never love one like you.
The next slide, it shows methodology. The first one is apparatus. We have burette, pipette, volumetric flask, beakers, and conical flask, analytical balance. And the next is chemical reagents. We have 0.1 mole NaOH, 0.05 HCl, and sample, phenolphthalein indicator, and also distilled water. So now, we go to the next slide is preparation of NaOH. For the first step is, we must to weigh 1 gram NaOH pellets, and then it must be dissolved in 50 ml distilled water in the beaker. Next, we must to transfer into 250 ml volumetric flask and dilute to mark with distilled water. And the last step is we must to shake to mix it well. Next, we go through the preparation of NaOH. For the first one is pipette 25 ml of the standardized 0.1 mole HCl into a 250 ml conical flask. And then, we add 2 or 3 drops phenolphthalein to remain the solution colorless. And the next step is fill the burette with your NaOH solution, then slowly titrate the HCl with NaOH while swirling. The light pink color appears and stays for 30 seconds. And the last step, we must to record the volume of NaOH used, then repeat the titration until you get 3 consistent readings. So next, we look through titration of skincare A and B to determine benzoic acid. For the first step is use the burette with standard NaOH solution, then fill it with 0.1 mole NaOH. Use a 25 pipettes with the sample A, pipette 10 ml of sample A into a clean conical flask, add 2 or 3 drops of phenolphthalein indicator, place a white tile under the conical flask, and then titrate by slowly adding NaOH from the burette when swirling the flask. Stop when a prominent pale pink color appears, and record the NaOH volume used, and repeat the titration at least 3 times to get consistent readings. And then we must repeat again step 1 until 9 for a sample B.
In this experiment, we need to find the actual molarity of NaOH solution by titrating it with hydrochloric acid. This process is important so that we can use the accurate concentration of NaOH for the next titration step. So for step 1, we have to calculate the average volume of NaOH, and we have performed the 3 times of the titration of NaOH. So to get the more accurate result, we calculate the average volume of NaOH used and we get 19.15 ml. Let's move on to the determination of benzoic acid in skincare products A and B using titration with NaOH. So first, refer to table 1.2, which shows the titration result for skincare A. The titration was done about 3 times and the volume of NaOH used in the 3 trials were recorded. The average volume of NaOH used was calculated to be 12.52 ml. Next, refer to table 1.3, which same as the previous table, shows the titration result for skincare B. So the average volume of NaOH used for skincare B is 19.2 ml. These average volumes will be used in the next calculation step to determine the amount of benzoic acid present in each skincare product. For this slide, it shows the balanced chemical equation of benzoic acid and sodium hydroxide. So the main formula to determine benzoic acid is percentage of weight of volume in percent equal mass of benzoic acid over volume of sample in ml multiplied with 100. Let's look at the standardization of NaOH solution. In this step, we are standardizing our sodium hydroxide using hydrochloric acid as the primary standard. From the titration data, the average volume of NaOH was calculated as 19.50 ml, and the balanced chemical equation for the reaction is hydrochloric acid reacts with sodium hydroxide to form sodium chloride and water and shows a 1:1 molar ratio between HCl and NaOH. In the given data, Ma 0.05 m molarity of HCl, Va equals to 25 ml volume of HCl, and Vb 19.15 ml the volume of NaOH used. We use the titration formula MAVA over MPVB is equal to A over B. To find the molarity of NaOH with MB, we rearrange the formula and we get the standardized concentration of NaOH, which states as 0.0653 molar. Let's move on to the determination of benzoic acid in skincare A. First, we use the formula MAVA over MBVB equals to A over B, and we insert the value of VA, MB, VB to find the MA. And we get MA equals to 0.0818 molar. Step 2, we find the moles of benzoic acid equals to MAVA, and we get 8.18 multiplied with 10 power of -4 mole. The last step, we have to find the percentage of benzoic acid using mole multiplied with molar mass, and molar mass benzoic acid is equal to 122.12 gram over mole, and we get the mass of benzoic acid which 0.0999 gram, and we have to find the percentage of benzoic acid using the previous formula in that show the main formula of determine benzoic acid, and we get 0.999%, which the standard limit for benzoic acid in skincare. We have to find the molarity of benzoic acid first. So we use the formula MAVA over MPVB. It is equal to A over B, and we get the molarity of benzoic acid which 0.1243 molar. Next step, we have to find the moles of benzoic acid using MA multiplied with VA, and we get 1.243 multiplied with 10 power -3 mole. And next step, we use formula mass equals to mole multiplied with molar mass of benzoic acid to find the mass of benzoic acid, and we get 0.1518 grams of benzoic acid. The last step, we have to find the percentage of benzoic acid in skincare B, and we got 1.518%, which is more than the standard limit of benzoic acid contains in any skincare. So skincare A more safer than skincare B, because skincare A have the standard limit that standardized in every skincare product.
So, after completing all the compartments and all the components in our research, we make a round of a conclusion, which is the concentration or mass of benzoic acid was calculated accurately. The experiment demonstrated the effectiveness of titration as a quantitative analytical technique and highlighted the importance of careful measurements and serialization to ensure reliable results. The amount of benzoic in the given sample was successfully determined using an acid-based titration method, specifically back titrations.